So let's start with the chapter number 4 of standard 9, measurement of matter. So this chapters divide 4 part: the law of chemical combination, atom safe mass valency, molecular mass, and the concept of mole and radicals. So chapter number 4, measurement of matter. Laws of chemical combination. The composition of substance changes during a chemical change. The fundamental experiment in the regard were performed by the scientists in 18th and 19th century. While doing this, they measured accurately the substance used and formed and discovered the law of chemical combination. Scientists could then write the molecular formulae of various compounds on the basis of Dalton atomic theory and the law of chemical combination. Here we shall verify the law of chemical combination by which known molecular formula. Molecular formula. Suppose we take the example of water. So atom of hydrogen and oxygen is combined to form. It is known as the molecular formula of water, H2O. Is it clear? Now the next part, law of conservation of matter. So in the above activity, the mass of the original matter and the mass of the matter newly formed as a result of chemical change are equal. In 1785, the French scientist Antoine Lavoisier inferred from the research that there is no rise or drop in the mass of the matter during a chemical reaction. In a chemical reaction, the total mass of the reactant is same as the total mass of the product formed due to the chemical reaction, and this is called the law of conservation of matter. Law of conservation of matter. It means left hand side, the mass of left hand side is equals to the mass of right hand side. When the reactant and product both are same masses, it is known as the law of conservation of matter. Now the law of constant proportion. In 1794, the French scientist J.L. Proust stated the law of constant proportions as the proportion by mass of the constituent elements in the different samples of a compound is fixed. Suppose the example, the proportion of mass of hydrogen and oxygen in water obtained from any source, that is 1 and 8. This means the 9 gram water is formed by the chemical combination of 1 gram of hydrogen and 8 gram of oxygen. Similarly, the proportion by mass of carbon and oxygen in carbon dioxide obtained from any source is 3:8. This means in 44 gram of carbon dioxide, there is 12 gram of carbon and 32 gram of oxygen, so that the proportion by mass of carbon and oxygen is 3:8. Is it clear? Suppose we take the example of carbon dioxide. So the mass of carbon, it is 12. Mass of oxygen, that is 16 into 2. Okay, it is clear. So that is 12 plus 32. 12 plus 32, it's make 44. It's clear. So it is given here the 44 gram of carbon dioxide. So there is 12 gram of carbon and 32 gram of oxygen. So what the proportion of that? So that you can find out, that is a 12 upon 32. So 12 upon 32. If you cancel with the 4, so it is 3 ratio 8. So that's why it is given 3 ratio 8. The same way for water, H2O, hydrogen, that is 1 into 2, oxygen, it is 16. So 2 upon 16, what the proportion is there? We can cancel it with the 2, so you get a 1 upon 8. That's why for water it is given 1 upon 8, 1 ratio 8. Is it clear to all of you? Now here we can see the atom size, mass and valency. This table, it is an important part of this chapter. Name of the element hydrogen. Symbol, it is H. Atomic number 1. Number of protons 1. Number of neutrons nothing. Number of electrons 1. Distribution of electrons, that is in different cells. K, L, M, N. So what the valency? 1. So here we can see how to form the molecular formula with according to their atomic masses, atomic numbers. For helium, it is 2. Number of proton, it is 2. Number of neutron, it is 2. Number of electron also 2. So distribution of electron is 2. Valency nothing, because the first cell is completed. It's a noble gas, it's a stable gas. Okay, it is cleared. So like this all is given, this you have to by heart, and it is compulsory. It's going to be asked in paper. That valency we can see later in the same lesson afterward, how to find the valency of any elements. Now the next part we can see chemical symbol of elements. Dalton used a certain sign to represent element. For example, hydrogen, it used H. C for copper. Today we use the symbol determined by IUPAC. The full form of this word, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. That is the full form of IUPAC. These are officially named a symbol and are used all over the world. The current method of choosing chemical symbol is based on a method invented by Abruzelius. According to the method of the symbol of element is either the first letter of the first and second, another specific letter in the name of the two letters. The first is written as capital letter and the second is small letter. Same for the carbon. For carbon we are using C. So it's not possible to use a C for the copper, only C. So for the copper that we use a different symbol. Is it clear? This is an important one that you have to remember. IUPAC is full form International Union of Pure and Applied Chemistry. So here we stop the first part. The next part we can see in the next part of this chapter.